All right. Can you guys see my screen?
We can indeed, yes.
Great.
We are live on Twitter and YouTube as well.
Thanks, GB. So let's kick off. First of all, welcome back to the CTO office hour. And in today's session, we're going to talk about how you can possibly contribute your staking contract to Collab.Land so that you can utilize the staking contract for token gating purpose. So before we dive into the details, I want to give a little bit high-level picture here. So as you can see from our screen, I kind of show how the different pieces are working together. But to give a little bit context, so a while ago, some communities started to ask us, hey, what's the possibility for the staking contract as a social truth so that for those members who stake their tokens with the staking contract, they can still get the roles they deserve because physically speaking, the tokens are still being owned by the user, right? But that actually creates an interesting challenge because typically on blockchain, there's different standards for the fungible tokens and non-fungible tokens. On the Ethereum side, usually you have ERC20, ERC721, ERC1155. But when it comes to staking, it's a very wild world. Like we don't have any standard staking contract that all the projects use. So that makes it so difficult for Collab.Land to understand what stakes a user have for any given, governance token, right? Then we figure out, okay, maybe the best way is to embrace that reality and create a mechanism and create these open source projects so that whoever interested to make the staking contract available to Collab.Land, they can contribute to that. So we kind of jumpstart that effort by this open source project. So what you see here is on GitHub, and each of you can contribute to that. And from the architecture perspective, we use this very powerful design pattern called extension point/extensions to glue all the pieces together. So from the Collab.Land token gating perspective, we would love to have a common interface to work with so that we can bridge through the different implementations to support many different forms of staking contract, right? So in the Collab.Land runtime, we only talk to this staking contract service. So this serves as an extension point, which kind of define the common denominators, or the different, the same behaviors coming from different staking contract. Then we create this interface called staking contract adapter, which serves as the agreement between the different staking contract to our system. And in the interface, we have a couple of methods like, hey, you can actually get the stake token IDs if that's for NFT by the wallet address. Or if that's a fungible token, you can get stake token balances by the wallet address. Right? Then logically speaking, this is a user, right? So initially when you make the NFT or you actually own the ERC20 tokens, you have an original contract. Then if you decide to stake that token to a staking contract, then you have to, move some assets from the original contract to the staking contract. So the staking contract usually have a couple of properties, like what's the chain ID, what's the contract address, and what are the different set of asset types it allow the original token to be staked, because some staking contracts supports multiple type of assets, like they can serve as a general purpose staking contract, right? So this is a little bit high level to give you a overview, like, how the different pieces are being connected to each other. Then I want to dive into what it takes to contribute a adapter for your staking contract. And so the timing is great because this morning I just saw somebody ping me from the Discord channel say, hey, I actually submit a pull request to the GitHub repo, and please review it. And I could just use this pull request to show what it takes to contribute a staking contract. Okay? So I think that's really meaningful because really the code is being written by our community member, and I can just show you how exactly this will work with our system. Right? And I can have a very quick walkthrough for the pull request we're seeing here, and I'll give you some pointers for some of the key information we have, and also show how we review the pull request and what it takes for any community member to contribute the staking contract to our system. Okay, so looking at this pull request, we see a couple of changes here. So first one is under the contracts folder, right? So we see this ABI because the idea is when you work on Ethereum smart contract, the ABI defines the different methods, the input, output, and all the different events. Okay, so we use a library called type chain, which can meaningfully generate TypeScript code from the JSON format of the ABI. And what this community member have here is it's called like a reporting staking.json. And this JSON document can be copied from Etherscan, Polyscan, or from your source code. Okay? So once we have this, ABI JSON into the contracts directory, then when we run the npm run build, we'll start to generate the code into our system. And then your implementation for the staking contract adapter can utilize that. Then let's switch to this, implementation. Okay. So the couple of things. One is we have this new staking contract adapter that extends the base staking contract to make your life a little bit easy. And then there's a few critical information, and the code is actually pretty straightforward. So first though, we have the contract address for your staking contract, and what's the chain ID. This one happens to be on Polygon, right? Then we have an array of staking assets, meaning what asset can be staked into this contract. This is the original contract we care from the token gating purpose, but now you're extending that ability to this staking contract, so we can own the ownership there as well. Right? Then there's a little bit technical nuances here. So we built this project using an open source project called Loopback. It's a Node.js TypeScript API platform, and one of the powerful feature of Loopback is to allow the dependency injection and support the extension pattern. So basically, we have some TypeScript decorators here. So the first one is say, okay, this class will be a singleton, meaning for the whole runtime, we only have one single instance of this adapter to minimize the overhead. And since this adapter does not keep any state per request, so it's perfectly fine to be a singleton. The second part is actually interesting because we talk about how we contribute to the staking service, right? So this decorator says, okay, this adapter will become the extension for this particular extension point. Then the loopback runtime will discover all the different adapters from the code base. Then we stitch them together and have the runtime just do the delegation based upon the different attributes. Say you pick up a staking TGR from the command center, then we'll figure out which contract address we'll have to look up the ownership. Right? Then from the business logic perspective, there's just a couple of very simple method implementations. For some of them, it's just a strict delegation to the smart contract itself. So for example, we want to figure out for any given wallet, what are the token IDs that wallet owns, right? So in this case, because the ABI generate this Preparium staking factory, then we just say, okay, let's create an instance of that contract by connecting to that wallet, the contract address, and we have a provider for the Polygon blockchain, right? Then we just say, okay, let's just call that view methods from the staking contract. And similarly for the balance, it's the same deal, right? So this is as simple as this, and then you can actually contribute your staking contract to your ecosystem. Then where's the magic for Collab.Land understand now we have this new staking contract. So we have one place to do that kind of registration. Basically, we have this so-called component. And in this component, you basically just list your adapter as one of the services. And with this listing, the loopback runtime will be able to, discover this adapter and make that part of our delegation ecosystem. Let me switch to that code a little bit and show you how that happens, right? So I mentioned we have this so-called extension point service. So again, this is a loopback service, and we mark it as a singleton, and we also give this service a so-called binding key. So binding key is how all the services connect to this service as a dependency, right? And what's interesting here is we use this as another special decorator called extensions. So the extensions basically tell the system, hey, let's collect all these staking contract adapters that declare themselves as an extension to the staking adapters extension point, right? So using this pattern, we decouple the adapters from this common interface, right? Then very much like the extension points just do the delegation. We try to figure out, hey, what's the contract we have to interact with, and which adapter we have to use to implement the common behavior. Right? So that's pretty straightforward. So we already received quite a few adapters, and the adapters are for different purposes. Some of them are ERC20, some of them is ERC721, some of them even use the REST API to get the stick, ownership, right? So for example, this one is the ERC20 staking adapter, and it's pretty straightforward. And as you can tell here, it's very much just connect to that contract address and then call the view methods directly from the contract. Then we have all the ERC20, ERC721. So it's all similar, but the tricky thing is each of the contract have a different view method. For example, this one is to say get stake info, right? So that's another one. Then we also have ones that use the GraphQL API. Say this one is okay, the rental NFT adapter, and this rental NFT adapter is basically just use the GraphQL API to figure out what are the ownership on that staking contract for rental, right? So it's pretty straightforward. Then you can just contribute by yourself. But going back to the pull request, right? Now we have this pull request coming. How do I review it, right? So first of all, I make sure all this addition to the system makes sense and follow the README we have here. So in the README, we have a kind of like a checklist. Okay, when you decide you want to add a staking contract support for Collab.Land, what information you need to collect, right? So what chain is that staking contract on? What's the contract address, and what's the ABI, and how do you, code that logic? And that will becomes the extension code for your staking contract. And I just walk through that pull request. And this is one example to show the different things and the different steps you have to do. So you contribute this, you drop in a ABI so that you can run npm run build that will generate a bunch of TypeScript client code to make that strongly typed, make it easy to interact with the smart contract. Secondly, you contribute adapter implementation. Then you register component you register adapter to the component itself, right? Then afterward, you can run the test, right? And one thing I want to point out is for the open source governance, we request you to sign off the commit so that it shows you, assert yourself as the developer for this piece of code, and you are giving that to be part of the open source project, right? Then once you do that, after your pull request has been approved and merged, then we are going to publish a release to NPM. So we have this, at Collab.Land staking contract, NPM package, right? Then we basically just, merge this dependency to our runtime so that your staking contract will show up in the command center for your members to use. Then kind of going back to the review, I'm really looking at, how we cross-check the, staking contract, right? So from this PR, I can actually get the contract address and I know which, blockchain we're going to use. So this way, like I can just go to the block explorer, like say on Polygon, I use Polygon scale, right? Now I can look up the contract by this address. Then from this address, I want to show you how typically you will get the ABI, right? So I think toward the end of this thing, there's a button for you to get the ABI. Yeah, so here, you can say, okay, I can copy the ABI to clipboard, right? So this is how we actually can copy the ABI. Then when you create a PR, you kind of adding that to here. And the one thing I want to remind you is typically in this, ABI, you also have the bytecode and you have the deploy bytecode. So we can remove the bytecode and the deploy bytecode because from the type chain perspective to generate the TypeScript code, you don't really need to have the bytecode. As long as you have the JSON structure to define the different view methods and the events, you're good enough. Kind of going back to that code level, right? And what's happening here is we have these generate types. So this actually represent the different interfaces we have for each of the smart contract, and we have the factory class that allows you to utilize the ABI and talking to that smart contract, right? Then for the moment, so very much like say when you pinpoint that smart contract, and especially if the smart contract have the source code verified with Polyscan or Etherscan, right? So you can pretty much just exercise and looking at the different view methods you have. For example, in this case, we have this get stake token balance, and you also have get stake token ID. So these are the two methods we using the adapter to talking to that smart contract, right? So now we have this pull request. So what I typically do is like copy the pull request ID. Then this way we can use the GitHub client that can check out pull request for this particular pull request ID. Let's see, we use PR actually. GitHub client PR checkout. So now we create a new branch locally to represent this contribution from this community member, right? And what we can do is to run the NPM test. So as part of the NPM test, we rebuild the whole system and we generate if you look at here, right? So we are generating the TypeScript types from the ABI. Then we iterate through all the different adapters and they try to call the get token IDs and the get token balances for each of them, right? So this is the latest one being contributed to our system, and it's passing the test. So we are good here, okay? So sometimes I just make a comment in the pull request that, oh, do this and do that. And then sometimes I also say, okay, I'm going to make some minor changes for you, and I'm going to use this to push back to your repository that contains the pull request source code. Okay. All right, and I'm kind of going back to the PR again. Just want to make sure like we have one commit here, right? And if you look at here, that's the commit we have, and click into here. In the commit. So this is the sign off I was talking about, right? So usually when you commit the change to your repository before you submit a PR, you can use the -s to sign off the commit. And this asserts you owns the code you develop. You are the original developer for that code, and you are giving permission for us to use that as part of the open source project, right? So that's that, right? Then say, okay, if everything's good, and then I just say, okay, I'm gonna approve this pull request. Then we're gonna merge the pull request. Then we create a release and publish to npm. Then we pick up that from our main runtime for the backend. Then that will surface through the command center. Okay. So if we look at the command center side, so I'm going to log into command center. So I pick one of the communities and look at the TTR, right? Say I want to add a new TTR, and from here, I can start to, let's say, just pick out the mainnet for now, or and this one. Yeah, so for now, instead of using the typical one, I can support a staking contract. Then here's the list of adapters showing up here, right? So those are the ones we will use depending on what's a staking contract. So for example, for that new contribution, if we merge that and the publish release merge it into the main code 9, then it will show up here. So you can pick that one. Then you can define the balance and the attribute. So for the fungible token, usually you use balance, and for the NFTs, you can do attribute-based token gating as usual. Right? So that kind of completes the whole flow. Like you start contribute adapter for your staking contract, going through the review process. Then we create a release from the staking contract to npm. Then we kind of pick up the new version from our main runtime. Then once we push that into production, you will automatically receive a new addition here from the command center to allow the company admins to use the staking contracts as a switch. Yeah, I think that's pretty much all. It's not like a rocket science. It's actually pretty straightforward, and we can pretty much review this pull request in public, and that will give you a kind of like a walkthrough, like how everything are being pieced together and what you can do here. Any suggestion, any will be welcome, and this really is a community project, right? So we receive so many meaningful contributions here. Appreciate that, and hopefully you can become one of them in the near future. So I'm going to open the floor for questions to make sure like I can address any of the technical, non-technical questions here. So let's see if we have any questions from the audience.
If anyone has any questions, please feel free to write them in the chat, or you can raise your hand and we'll bring you up in the stage for you to ask your questions. In the meantime, we also have a POAP for today's CTO office hours. So maybe it's a good time to distribute the POAP while people think of their questions. Oh, we have one hand raised. So, okay, let's get to this question first, and maybe then we'll distribute the POAP. Let's see.
Yeah, UAB, you're on. Feel free to speak, I assume.
We sent you an invite to speak.
Oh, sorry. I think I was muted. Can you hear me?
Yeah.
Yes,
Yeah,
we can
Raymond.
hear you.
So basically, I had a question which I think I know the answer to, but like I just wanted to share with everyone here. So basically, I think right now this repo maybe only supports EVM chains, uh, and like there are mostly contributions for like Ethereum mainnet and Polygon so far. So like, can anyone list like any other EVM chains taking contracts as well, like which we support right now by default using the template you shared, or they'll need to do some more work?
So for the runtime, we support any EVM compatible blockchains. So as it kind of showing up in that contract, right? So for the contract, you can override the chain ID to tell which blockchain you are on. But when it comes to this command center UI, I think we only enable for mainnet and Polygon at this point. But it should be easy to enable other ones because the rest is the same. So the runtime support different EVM compatible blockchains, but the UI right now is only being constrained to allow mainnet and a Polygon.
Mm-hmm. Good. Thanks.
Any other questions? This is actually another work in progress adapter. I should review that as well. Okay, so it's still a to-do. It's not finished, so not ready to go. But again, the implementation is quite straightforward. Like for example, they just have different methods on the smart contract. So this one is called get stake position instead of get stake token balance. Right. So I wait for this PR to be finished before we can review it and merge it. And thank you for sharing the half docs. It will probably cover most of the technical issues here. But in general, it's fairly straightforward. It's not a rocket science. You can do it, and we make it easy for you to do so. Uh, just get your hands dirty and try it. All right. Anything else? If not, then we can have Chibi to drive the phone part, which is the pull-up. Chibi, are you ready?
I am ready, yes. So let's get to the POAP, and if anyone has any other questions, please feel free to bring them up in the chat, or you can raise your hand and we'll bring you up in the stage, just to mention that once again. And now for the POAP. For everyone in the audience, if you would like to claim today's POAP, we'll be using the POAP mini app here in the Discord server. And you will have to use the slash command POAP claim. So that's slash POAP claim. And the claim phrase for today's POAP is taking collab, all lowercase and with no spaces in between. Again, that's staking collab. Once that you write it down, hit enter and you'll receive a code to claim your POAP. Please let us know if it works. I just got my code, so let's go ahead and claim the POAP. Awesome. Once again, the secret phrase is staking collab, all lowercase, with no spaces in between. I just got mine as well. I say it a lot, but I love the POAP mini app. It's so easy. And also importing events is like instant, so it just makes my life easier. Amazing. Also, you guys, and for anyone watching this recording in the future, if you have any questions, also make sure to bring them up to future CTO office hours. And Raymond will be happy to assist you with your questions.
Yeah, absolutely. All right. Thank you so much for attending today.